Series B startup gave me a take-home assignment. It was a very interesting problem from engineering point of view. But what's more interesting was their interview process. Instead of just sending me the assignment to take home and try to solve the problem before talking to me, an engineer sat down with me for 45 minutes to understand how I would think and how I would approach the problem, which was very interesting. And we had a very good discussion. I learned a lot. I learned a lot about databases in probably 4 or 5 hours of solving and interviewing than ever before. What you're about to watch is my thought process and an architectural higher level approach on how I solve the problem and how I optimize it. Let me know what you think, and if you have a better solution, I'd be very happy to understand. And yeah, if you like content like this, please like, share, and subscribe. Let's try to understand what's the actual problem statement first. So we have two databases. On the left side, you have source database, and then on the right side, you have a destination database. So your job is actually to bring everything from the source database to the destination database. Every single table, every single row. What you don't have to worry about is the schema is same on the source database and the destination database. You don't have to worry about the foreign keys. You don't have to worry about the primary keys, the columns. All these things are already set up. So your job is to build a bridge between these two, like a process that copies everything from the source database and brings the same thing to the destination database. Your process can be anything. Your process can be just anonymizing the data. Before we go any further, this is not a sponsored video, but I've been using Whisperflow for last one and a half month, I think, and I've been loving it. Instead of trying to type and talk to Cloud Code to get work done, I've been just talking to my computer. I've been a lot more productive, and it's a very interesting way because I never thought I would enjoy talking to computers, but Whisperflow does this work so beautifully. And yeah, if you want to try, there is a download link, affiliate link obviously, and I'll get a commission if you download and purchase it. Give it a shot. It's really worth it. It really saves a lot of time. Now let's get back to the video. Now that we understand what's the problem, let's try to solve this in the most simplest way first. So the simplest approach is for each row, for each table, let me change the color so we can put a for loop for each of the tables on the source database, and then we can process each row one row at a time, which means, so for each row we can do three things. We can do one, read the row, and then second, we process this row. This is where you can anonymize the data, and third, we can write into the database. Read is basically, in a simple Postgres or MySQL, you can say this is a select statement, and this is where you can process, and this is an insert statement. This would work absolutely well. For example, in this case, we have 10,000 rows, which means for 10,000 rows, we are doing this 10,000 times. This is one full cycle for one 10,000 rows table. If you have a million rows, then it's a million times. If you have 10 million rows, it's 10 million times. So it's going to scale very, very fast. And as it scales, it becomes a lot more slower. And something to remember in Postgres is every statement that you're doing, you can select, insert, right? Like if, for example, if you say insert into let's say insert into let's call it a table users with the values, right? If this is your insert statement into the destination database, what's gonna happen is this is sent as a string, which means every single time you send this, it is doing bunch of things. It's gonna read character by character, which means I, N, S, E, R, T. So that is how it's gonna read, and then it's gonna parse it and then validate each of the values. It doesn't know what is the value that you're sending from the process. If it's an integer, it's trying to validate if the column that you're trying to insert into is also an integer, and then it's gonna convert into the binary that can hold in the database destination in the Postgres disk, and then stores it, which means all of these cycles every single time you read, process, and write, it's gonna happen million times and it's gonna slow down. The very first improvement you can do is stop talking to databases one row at a time. So what I would do is, instead of talking one row at a time, I would just batch it. So right here you're writing 10,000, if there are 10,000 rows, like in the example, you're reading, processing, and writing 10,000 times. So instead of writing, which is the most time consuming process, what I can do is I can just accumulate 10 instead of 10,000 rows, I can accumulate 100 rows at a time and then write it into the database. So here we are doing this in 10,000 times. We can just do that as 100 rows goes in one cycle. That means if there are 10,000 rows, now it just cuts down to 100 times. 10,000 rows. This becomes just 100 cycles. This will definitely improve the speed, but there's still better way of dealing with it. Before we go any further in optimizing, let's try to understand what is our bottleneck. What is where is the slow process? How does this whole thing work, right? So in general, reading from database and writing to the database is definitely considered slow because it's a network call. You're going out of your computer, out of your EC2, whatever you want to call it as, and then reading from there, and the network calls are always slow. This is the same case with reading and writing into the database. The fast process is this, because this is happening in CPU and it is also in memory. We are not storing, we are not writing, it's just happening in RAM. It is super quick. So if you think about it, all of these things are happening sequentially. You're selecting the row 1 and then passing it to the process, and process is processing the first row and then writing into the destination. Every single thing is happening one after the other. Like imagine if you can select a row and then give it to the process, and process is done, completed processing and anonymizing the data, and it's already writing into the database. Process is sitting idle, so is selecting the database is sitting idle. These three things can be separated out. Can we do all of this separately? Because at this point all of these three things are happening in the same thread and they're happening sequentially. So this is where you have to start thinking, how can I make this parallel from each? A solution to this bottleneck is making sure these three tasks run parallelly to each other with the two channels. So imagine channels are something like thread safe queues. So what I can say is, because reading from the database, processing, and destination, they are all running three parallel tasks. We are connecting them through queues. So imagine we have a queue here, and instead of just waiting to read from the database and then process, the reading is just happening and the first row just goes into the queue, right? Right here. So the first row goes into the queue, and then the same way the row 2, row 3. So we are just adding into the queue. The process has no idea about reading the database. What process is gonna do is just read from this queue, which means this two can be independent of each other. So this is the channel. Source is reading one row at a time and just putting each row into the queue. Process is processing one row at a time still, but in a parallel thread, in a parallel task, and reading from this queue. And at the same way, once it processes, we can just write into a we can just put that into a different queue. And destination's job, the writing into the database destination, that job is just reading from this and writing into the destination. This means all these three processes are independent of each other. If let's just say for simplicity's sake, if process is super fast and it's just writing, it's just reading one row at a time very quickly, it reads and writes, and then destination is taking the writing is happening automatically without the need for these two processes for the third process to complete. So all these three things are running parallelly at the same time. But now the question is, how would you think, what should be the size of the channel? Can the channel be unlimited size? Can the channel be, do we have to limit the channel to a specific set of size? So again, like now, instead of zooming in, you zoom out and think. At some point there is always a limitation of memory, right? So let's say you have a 10 GB RAM in your memory that is responsible, and this is, let's say it's allocated for just reading from the database and storing it in memory. The way I think about it is, if this channel is unlimited and you have millions of rows, this is gonna start at some point, because process might be taking more time, or there might be something that's taking more time in these two parallel tasks. If you leave it as like there's no constraints, this is gonna be again a bottleneck. So this is gonna start showing up, like if there are millions of rows, it's gonna just keep adding, like just keep reading without this any row being pulled out. So which means at some point it's gonna start having a issue, and then it's gonna crash. This is the thing you need to avoid. So there are two kinds of channels that at least I have seen in .NET. So there's an unbound channel and a bounded channel. The obvious answer and the safest answer to go is a bounded channel. So you can just say we will have 100, the size of the channel is 100, so that you can accumulate 100 rows at a time. And then in case if the channel is not empty, it is gonna wait, the thread is gonna wait before it can push any more selected rows into the channel. This is one way of making sure three tasks are running parallelly to each other in three different threads using two channels, and they are not dependent on each other. They are just independent tasks. One other thing I learned during this interview process is, like I said before, here we initially started with single insert, one insert at a time, and then we moved to inserting batch inserts. And then even in this process we can still be doing batch inserts, right? Instead of just doing one row at a time, we can have 100 of these rows in the memory and then insert it. But what's interesting, like I mentioned before, is the way Postgres works is it tries to read each of this string, the whole text, as one row, one character at a time, which means it is trying to read I, N, S, E, R, T, and trying to identify what does that insert mean. And then it tries to find the table, and then it also tries to validate if each of the value that you're giving, if this is an integer, and then try to convert that into it actually converts that integer into a binary format that Postgres can store in the database, in the disk. But what if we just do a simpler approach? What if all of this heavy lifting, instead of the Postgres database doing, what if we can just do that by our own app? That is happening in memory. Like I said, this is much faster. So instead of just copying the text and then passing it as a text, what if we just convert this heavy lifting that's done by Postgres in our app? This is what's called binary copy.